Welcome everyone to Water Around the World, Local Problems, Global Solutions. I'm so happy you're here today for our final Water Around the World of 2021. My name is Elena Harkness. I'm the Executive Director of Current, and I am very pleased to welcome our sponsoring partners today, the Consulate General of Denmark's Trade Council. We've had this wonderful series running all year long. Our collaboration with the Consulate General of Denmark's Trade Council has been a very strong one, and this is actually the fourth in a series that we've done this year, highlighting the leadership of Danish companies that are bringing transformative solutions to our water challenges, hopefully to bring them to ground here in the Midwest. And today's topic is really near and dear to Current. We are going to be focusing on the digital future for water utilities, something that is so important as we move towards future solutions to our water challenges here in the region, but also around the world. So thank you very much for joining us for this conversation. If it is your first Water Around the World or your first event with Current, welcome. We're thrilled that you're here and part of the community. We do like this to be an interactive session. So in addition to hearing from some wonderful speakers today, we'd love you to submit your questions for us. So you can put them in the Q&A tab, and also feel free to use the chat to connect with other folks that might be in the room today that you're interested in connecting with. This event, like many of our events, is being recorded, and that link will be shared out on Current's event page and our YouTube channel. So follow and subscribe to that if you haven't already. There's wonderful content on there from events that we've hosted this year and in the past. We'll also be sending that link out to you post-event, so feel free to spread the word, amplify, share on social media. So a quick agenda for the day. I'm really thrilled to have Sophie Thulgaard here, who's the commercial advisor to the Trade Council in North America at the Consulate General of Denmark. She's going to share a bit of framing about this relationship and partnership. And then we're going to hear from one of Current's we can't even say enough about Jun Hong, our lead water strategist and senior scientist from Argonne National Laboratory. He is going to share the problem statement, frame up this opportunity for us, and explain why it's so important that we're here to hear about digital water solutions. And then we'll have our presentation. So we're going to be hearing from 4 terrific Danish companies, and then have time for general audience Q&A. We'll get you out right before the top of the hour. So that's the flow. So first, just a bit of framing from Current's perspective. Why are we here? Why are we putting on these kinds of global collaboration events in our community? We're here, go ahead, George, next slide. Because of a shared vision that we all need more healthy water to drink and less flood water for our basements. This is something, these common challenges affect us here in Chicago and Illinois in the Midwest where we live, but they are also these challenges that face communities all around the world. And so here at Current, go ahead, next slide. We are also keeping a close eye on the way that water is being affected by climate change. Obviously, this is top of mind this week as the world meets in Glasgow for COP26. But thinking about how we build bridges between the solutions that our global partners, that our folks right here in our backyard in Chicago and in Illinois are coming up with. This is truly a global problem-solving community that we need to foster in order to meet the challenges that climate change is bringing to our doorstep. The deepening, increasing strength of rain, the flooding. Right here in Chicago, we are concerned about the fluctuating levels of our lake, our drinking water quality. So many of these challenges are going to require the connection of a problem-solving community that is certainly not just local, but will require deep local knowledge in order to implement these solutions. Next slide, George. So our problem statement is that we need to rally faster. We need a global problem-solving community that is more quickly bringing new ideas and technologies into the marketplace, into deployment to protect our health and environment. We know that innovation is difficult. It takes collaboration. Most often water solutions involve multiple disciplines, many different kinds of technologies. They're often system level solutions that we need to deploy. And so Current exists to build the kinds of partnerships that enable those solutions to come to market and go to ground faster among industry leaders, government, nonprofits, businesses that you'll hear from today, and researchers who are all trying to push the frontier of water problem solving forward faster. Next slide, George. And Current exists to be an unbiased advocate. So we are really here scouting and scanning for the best technologies wherever we find them. We independently assess them and then recommend them for others to try, or sometimes for us to pilot, as in the case of H2 Now Chicago, one great example of water quality monitoring underway here in the Chicago River that you see in front of you. But in this case, we are really excited to have scouted around the world and brought 4 solutions to digital water from Danish companies. And so we're really excited to feature them today. Next slide, George. Perfect. So now for a little more context, I wanted to turn it over to Sophie to share a bit more about this partnership and the goals that we had for it. So Sophie, thanks so much for engaging with us this whole year. Over to you to share more.
Hello, everyone. Thank you, Elena. My name is Sophie Thorgard, and I work at the Consulate General of Denmark out of Silicon Valley in California, previously Chicago. We run a water technology alliance, and we're here to share knowledge from the Danish water sector across the pond, and we're doing this through partnerships with associations like Current. We are a team of water professionals, including 2 of my colleagues who are on leave from their utilities in Denmark to share their experiences with digitalizations with you over here. You can follow our work by scanning the QR code on your screen with your phones. We're sponsoring this event series to create a focus on digitalization and how it really has moved the Danish water sector, and to highlight some of the great technologies out of Denmark. So thank you for joining us today.
Thanks so much, Sophie. We're so thrilled to have your partnership, and the Water Technology Alliance really encourage everyone to take a look, learn more about it. These kinds of alliances are how we drive the partnerships that can help us all move faster, which we know we all need. So now I want to turn it over to Jun Hong, who is, again, as I said, is the lead water strategist and senior scientist at Argonne National Laboratory, and also the Crown Family Professor at the Pritzker School of Molecular Engineering here at the University of Chicago. Both Argonne and the University of Chicago are longstanding partners to Current, and Jun Hong is going to frame up the problem here and why we are all here to bring these solutions to address it. So Jun Hong, thanks so much for being with us. Over to you.
Thank you, Elena. Good morning, everyone. I'm so excited to be here. My own research is about real-time sensors for detection of water contaminants. So today's topic is really dear to my heart, right? Digitization of water resources and water systems is simply the future. Right, in collaboration with Current, we're also in the process of forming a industry university cooperative research center on artificial intelligence enabled water energy nexus. So we welcome your input and support for such an effort. So what is digital transformation? Digital transformation uses technologies to shape your organization and help make the right decisions at the right time. Right? Why now? The rapid technological development is providing us with new resources and tools that are radically changing the utilities options for getting an overview of all assets and the entire system. It is no longer just a matter of increased accuracy. Advanced data analytics facilitate the digital transformation of wastewater and water utility infrastructure and generate value for existing data. It ensures utility management can translate critical information into actionable insights to expand efficiency, improve performance, gain reputation, and streamline critical infrastructure services. There's huge value in data, as we all know, right? But data is only useful when you use it. With modern technology, utility managers often get more data than they know what to do with. So how do you calculate the value it can bring to justify the investment? With the right tools, it is possible to maximize value through cost savings, investment optimization, and optimized workforce operations. American water utilities have always been dealing with problems caused by changes in their operating environment, aging infrastructure, extreme weather events, sanitary sewer overflows, capacity issues, energy issues, increased costs for treatment, and restrictive effluent standards, right? So disruptions such as water scarcity, floods, power outages, and pipe failures all test utilities' resilience. Response to the variable climate, extreme weather events, and issues as a result of these events has already cost the American open water infrastructure, millions of dollars. Consequently, water industry decision makers need decision appropriate techniques to use in conjunction with suitable data and information to make robust business planning and operational decisions for their valuable assets. At the outset of digitization, any digitization project, it is important to remember that successful solutions are a well-orchestrated mix of technology, processes, and people. Implementing technology per se is not the final answer, as it may even complicate the operational framework and reduce the overall efficiency. So a sustainable digital solution is therefore one that is affordable, addresses the specific needs of each customer, and evolves with them, and can be integrated safely and seamlessly into existing technology layers and data sources, whether they be intelligent devices or other legacy systems. So this morning you will hear a number of talks along these lines, right? So we really looking forward to these conversations. Back to you, Elena.
Great, thanks so much, Jun Hong, for highlighting, I think, some of the really important themes to keep top of mind. I mean, this is a really important moment, obviously, to maximize the performance of the infrastructure we do have, and also think about how we can really make the most efficient investments in the future infrastructure that we need. We know that we're going to have to do, the volume of the task in front of us and the scale is really significant. And so the pathways that smarter, digitization of these decisions, of the data and intake of these, all this information to make those decisions better and faster has the potential to not only save money, but really improve the results that we're delivering to people where it most matters. So stakes are high. Thanks for framing that up. And now I want to turn it right over to our first presenter, George of Statos from Comstrup, who's going to talk to us about ultrasonic leak detection. George?
Elena, thank you. Thank you very much. And hello, everyone. Thank you for making the time to be with us today. I am George of Statos. I'm the Senior Director of Sales for North America with Comstrup Water Metering. Digitalization for us really means it's intelligence. It's about the information we extract. It's about the transparency of being able to see what is happening in our systems. And like we talked about before, it's about the ability to react much faster than we otherwise would because of all this additional intelligence we have. When you think about what we do at Comstrup, our purpose, the value that we try to provide to the utility industry is really the idea around eliminating waste of water. Everything we do is about trying to use every drop of water that is produced, that is distributed, that needs to get to our consumers. But if you think about the technologies that have existed in the past when it comes to metering, which is what we do, we've done a phenomenal job of being able to measure water, identify what happens to water once it leaves the meter. But for the first time, what we're doing at Comstrup is this innovation that we've created is to identify what is happening to the water before it gets to the meter. So George, if you can go to the next slide, please. What we've created is a solution that we call acoustic leak detection. It comes in 4 parts. And I want to break this down just to make sure that everybody's on the same page in terms of what the pieces look like. The first piece is obviously the water meter itself, being able to now monitor noise levels within the distribution system and to do it with each and every meter that exists in the system itself. Once we collect that data, then we move to noise data management. The ability to have this monitoring event going on throughout the network on a 24/7 basis, having that near real-time visibility in terms of what is happening in our distribution system. And then the information that we're able to take from that, putting it into a digital platform where now our stakeholders, utility stakeholders, are able to prioritize the maintenance and the activity and the spend and the investment that they want to make to modify and improve their infrastructure. And then the last piece is the actual repairing piece, is once we've identified where the leaks are, identify how big they are and how important they are to the system, then actually deploying the work crews in a much more expedient manner so that we are actually reducing the leak runtime. George, next slide, please. So in an effort to try to level set everything, this technology has existed before, right? So we've had water meters before, we've had leak sensors before, we've had radio technologies that communicate that through AMI networks. What I wanted to show you with this slide is simply the fact that all of this technology, our innovation approach, is to take all of this technology and embed it within the water meter itself. So all the wires, all the various components are now gone. Next slide. So please scroll through that if you would, George. So what that means to us is as we look at having this technology within each meter, we're actually multiplying the number of sensors that we are able to deploy throughout the distribution center in orders of multiple magnitudes. Every meter now has the ability to hear for noise, whereas before, the older technology, we were only able to put a smaller scale, a smaller number of these sensors. And what we believe is that the performance of being able to identify bad areas, leak areas, areas where we're losing water are now going to surface and give us that visibility that we so desperately want. Next slide. Oh, please scroll through. Okay, so this is 3 examples that I'd like to share with you in terms of what our digital solution has created, has been able to achieve. This is our platform where we're now taking all that noise data and we're now presenting it to the various stakeholders. What you see is a graph with different color codes for each meter. The red identifying the fact that we're sensing some high level noise within that area. The graph on the right is a representation of what that noise level looks like. In this case, what we've been able to do is identify a leak that was growing over time, fix the leak, and then what you can see in the September 10th timeframe, once that leak was repaired, the noise level came back down to 0 and stayed stable going forward. This was an example where we identified a leak in the main of anywhere between 13 to 17 GPM. Rather significant loss level. Next slide. This is an example where we started to see a leak, started to sense some noise levels, noise activity in the late August timeframe. The crews went out, they repaired the leak came back down to 0. It stayed at 0, but then we started to see over time that it was developing some additional noise levels. And what we found is that because of the age of the infrastructure, a secondary leak had started to occur. In this case, the noise levels started to spike, the leak was repaired, the noise levels came back down to 0 and stabilized going forward. Next slide. And then finally, this is just an example of how much this could cost. This was an occurrence with one of our customers where we identified a leak that they estimated was going on for over 4 months. And to try to put some real numbers to what that means, that leak was going to translate to about $21,000 in lost revenue for the utility. Typical example of what we find on a regular basis with the various deployments that we have around the country. But this is in essence what we're trying to do. So George, last slide, and if I can just summarize, what we are trying to do through Campstruct is providing the technology, the data, the information, and the actionable insight so that we can give that full transparency to our stakeholders so that they can react much faster to the problems that might exist within their system. And I'd be happy to take any questions if anyone has any for me. Thank you.
Great. Yep, we do have a couple. Thanks so much for this presentation, George. It's such an important area and certainly a common challenge wherever water systems exist in the world to make sure we're preserving every drop and getting it to the people that need it. So a couple questions. One, how does the acoustical system estimate the volume of the leaks? Like, can you share a little bit more about the mechanics of how that works?
Yeah, sure. So what the system does not do is measure what the rate of loss is. So what we're doing is we're simply measuring the noise level that leak is creating. And that's what we're trying to identify. So and we're doing it, we have algorithms built into the software that allows us to filter out false noise from what could be a real leak loss. But I want to be real clear about that. We're not actually measuring the loss. We don't identify the rate of the loss until we get to the site and we're able to discover the leak. So step 1 is about identification. Getting to the leak faster, and then repairing it as part of the process of completion.
Got it. And then an interesting question about the distinguishing between the public and private sides of the meter. Is there any way to distinguish whether or not the leak is originating on one side or the other?
Oh yeah, for sure. So the meter before this innovation took place has the ability to monitor and identify leaks that are happening after the meter. There are alarm codes built into the meter that suggest that, hey, there's been water running for a period of time. It hasn't stopped. It should have stopped. And what the meter will do is trigger an alarm code that notifies the utility that the customer might have a problem on their presence. The other part, the part that we're talking about today, identifying it before, is the data that we would capture that helps us identify the noise levels before in the service line and in the main line, depending on the location of the leak. So we have, I guess what I'm trying to say is we have two different sources of information that help us determine whether or not the leak is happening before the meter or if it's happening afterwards.
Great. I think that answers one of the other questions, but final question, maybe before we move along, then we'll see if we can get to the end and come back. But is there a calibrated hydraulic model that is needed to do this analysis, or what helps you transform that signal or that noise, I guess, into signal?
Well, the meter itself has a sensor that's just simply listening for noise levels. So once the noise, what's nice about it is that the noise will travel with the flow of water. So depending on where the noise is, all the noise has to do is get to the meter. Once we identify it, then through the algorithm and through the platform and through the solution that we call leak detector, that's how we monitor and measure whether or not the noise level is getting louder or quieter over time.
Great. And then one question, can you give an order of magnitude for installing this in a utility with 5,000 connections? And I think by order of magnitude, maybe we're talking about cost estimate. So
for 5,000, so this is an AMI, this is part of our AMI solution, traditional AMI solution. And what we're doing is we're separating the value or the acoustic leak detection service separate from that. So if the utility is looking just for a simple AMI solution without leak detection capabilities, then that would be one price. But activating it would just simply be through a software as a service type of fee. We don't, and the numbers do fluctuate. I'd rather not give general numbers, but if there's somebody that would like to talk to me about that, I would be more than happy to dive
We'll definitely make an offline connection. Yeah, that's really great. Terrific. Well, I want to move on. There's lots more questions, which is great. Please keep them coming. Next up, we have Steve Frangione from Grundfos, and he's going to talk to us about remote management and machine health for pumps. So thanks again, George, and Steve, please take it away.
Great. Thanks, Elena. Hello, everyone. Yeah, so today we're just going to look at how Grundfos has created some newer digital products and how it fits into the digital space and helps customers solve some of the everyday challenges that they face with our digital solutions. So if we could just go to the next slide, I'll just do a quick introduction on myself. So as Elena said, I'm Steve Frangione. I'm the product manager for water utility controls in the Americas for Grundfos. I've been working in the industry for about 4.5 years now and have been with Grundfos for almost 4 months. So still fairly new, and it's just about enough time to learn the different acronyms that we use for all of our products. So today we'll just do like a quick little crash course on a couple of those different acronyms within the digital space. So if we can go to the next slide, we'll just take a look at an overview of some of our control solutions and digital products as well. So those of you who already are familiar with Grundfos, and even if you're not or heard the name before, I think we're mainly recognized as a pump company, and which is relatively unknown is our capabilities within pump controllers or the digital space. So here's just kind of an overview of the different products that we offer, from electronics like pump controllers to some of the accessories that you see on the right-hand side here, VFDs or power monitors or communication modules. And we also offer some digital solutions as well. So today, we'll take a look at a couple of the different digital solutions that Grundfos offers. So we'll take a look at the next slide and look into the first digital solution, which is referred to as, once again, you see that acronym GRM, also known as Grundfos Remote Management. And this is really an out-of-the-box cellular-based remote monitoring system for water and wastewater pump stations, pumping systems. This gives the user access to their system via a web-based interface. So really convenient out-of-the-box solutions, for wastewater or water operators who were going to stations every day to pull runtime information or anything like that. Now they can do it really with the convenience in the palm of their hands with an iPhone, a tablet, or while sitting at their desk or at home. And really the main concept behind this solution is we're taking information from the installed field sensors, connecting it to our controller, sending it to the cloud, and displaying it in what is really just a user-friendly dashboard. So, the end users can analyze their systems, the functionality and the performance of their system while sitting at their desk. The system's also going to generate alarms or text notifications during any events or faults, if any faults occur. So we'll go to the next slide and just take a look at the user-friendly interface. So, it's really a text-based report-like format that's familiar for our operators. They're used to dealing with reports on a daily basis. So I think this makes it really convenient to go in and see how your system is performing. We'll just take a look at some of the different information that's being brought in here and displayed. So in the bottom left-hand corner, you can kind of see just some of the pump stats. So what position the HOA switch is in, which is actually really convenient. So, you have an operator go out in the field and if they're carrying out maintenance or pumping the station down, sometimes it's easy to forget what position those switches are in. And if you leave it in hand, you can run into some issues. So the status of that HOA switch is actually displayed in GRM. So you can see the actual position of that switch. And the user can control that HOA position as well. So if they want to turn the pump into hand or off or auto, they can actually write the data to the controller from this interface as well. Up in the right-hand corner is more of like a station overview. So this is going to provide statistics such as like total operating hours or flow or energy usage for the entire station. And then just in the bottom right-hand corner, you're just going to see like a log or a data logger shows you event histories, if there was a fault or, something changed at the station, it gives you a timestamp on that as well. So we'll go to the next slide. And this shows you the flexibility of the system. So with this type of device, it's really a communication module or like a piggyback device that can work with third-party control systems. So it doesn't necessarily have to be a Grundfos controller or pump station for us to provide the customer with remote management or monitoring that station. So this device connects to third-party control system and gives the user an interface to monitor that remotely and still generates those notifications and calls them out remotely. Next slide, please. So within the Grundfos Remote Management tool is also a powerful trending tool, and it's going to allow the customers or the users to identify critical parameters that may have been off the radar or not really on the radar at all before installing the system. So this particular snippet is from an installation where prior to installing GRM, the customer was having some intermittent failures with the pumps kind of kicking on and off, and they weren't really sure what the issue was. So they were able to install the GRM system with our power monitor and get live data of, you know, the three-phase power and energy consumption. So after hooking it up, we could look at the trend and see these abnormalities in imbalances in the current. So they were able to take a look at this and really identify what the issue was, and then carry out maintenance based on that information. Next slide, just to wrap things up on GRM before we move to our next solution. So why GRM? And that's a good question, because there's a lot of different systems and remote monitoring that are available today. And some of the things that are so beneficial about GRM is that it's out of the box and it's easy to install. And you can have a system up and running within just a couple hours. And another big benefit about GRM over some of the other solutions out there is that it gives you the ability to read the information, monitor it, as well as control or write data to the system. So, you know, you can turn pumps on and off or change set points from your office, which isn't available on some of the other systems out there. So we'll go ahead and take a look at the next slide and kind of transition over to our next acronym or digital solution. So this is referred to as Grundfos Machine Health, or GMH. And it's really a newer tool that uses machine learning software to enhance this overall system performance. And it's quite universal in terms of the industries or fields that it can be applied to. And, you know, today with processes relying so heavily on optimal performance from rotating equipment, this system really helps ensure optimal performance while reducing energy, reducing downtime for the consumer, and also saving money on which can be costly repairs if some of these things go unnoticed and just work to the point of failure. Next slide. There's really three main concepts of the GMH system. And it all starts with connecting the sensors to the piece of rotating equipment. So with GMH, there's going to be smart sensors that are connected and transmitting data to our cloud services really 24/7. So these are always collecting data and sending it to the cloud, which are, you know, they're monitoring temperature, vibration, acoustic stability of the system, and magnetic flux for like dried install applications. And this could really be, you know, any application from commercial business like a booster system or manufacturing to larger compressors and machines like that, or in wastewater as well. So the installation process is actually really simple, just a matter of hooking up the sensors, and can be done within just a matter of a couple of hours. And then the next step, the diagnose step, would taking that data, sending it to our machine learning software, our algorithms, and giving an output to provide the user with intel on the overall health of their machine. So some of the things that can be detected pretty easily with this system are cavitation, resonance, bearing wear, misalignment, and a bunch more. And then the improved step. So the output from that artificial intelligence, if you will, or those algorithms, really allow the users to make decisions or data-driven decisions based on how that system is performing. So they can carry out maintenance really before things get to that catastrophic point. Next slide, please. Once again, just kind of looking at the process or the overall concept of the system with the connected sensors being displayed on a user interface, you know, like in your tablet or on your computer, on your dashboard. And one thing that is unique about this system is there's also like the human aspect. So it's a service that Grundfos provides that constantly has technicians monitoring the system. So we can detect abnormalities such as like if they were doing construction out at the site causing abnormal vibrations to the system that were kind of outside of the trend, a technician can get notified and see that information and identify, okay, this is just construction. This doesn't really fit with the data that we've been collecting over time, and notify the user. So it really just kind of adds an extra layer of protection or peace of mind that having that you know, that human aspect involved. So even if the operators miss something, Grundfos is still able to kind of step in and help them out. Next slide. And this is just a quick example of the dashboard. It displays some of the different features such as like asset management or the trending or fault analysis. And while I have this up, I just want to talk about like a quick case study for a customer in the US that was using this software. It was in a manufacturing plant and they were using GMH as just a trial run. They wanted more information on their system. So shortly after it was installed on a large compressor pump, the system was able to pick up like abnormal signals and identify there was actually a worn thrust bearing. So with that information, the customer was able to repair the machine on their own time for just a few $1,000s versus letting that go until failure and having to replace a piece of equipment that was up to like $250,000. So there's the value in having kind of that predictive maintenance versus preventative. And on top of saving the equipment, it gave the customer to really manage the downtime and carry out maintenance on their own time. So that just kind of wraps things up about GMH. If you can go to the next slide, you'll see just a link where you can find some more information on the system. And what I'll do is I have a few links to different brochures and this Technical Institute, or GTI, another acronym there. And I'll go ahead and put those in the chat just in case anyone wants to get some more information on that.
Terrific. That'd be great. Thanks, Steve. Put links in the chat, and you can also encourage some questions in the chat. We don't have time for any right now. We've got to turn it to our next speaker, but that was terrific, and lots of opportunities to, of course, save money, improve efficiency there in that. So we're going to turn over now to Lars Limke-Svensson from Apex 10, who's going to talk about asset management. Lars, the floor is yours.
Thank you, Elena. And yes, I'll talk a bit about Apex 10, who are a company in the Nordics who are making asset management software for utilities. And I'm Lars Limke-Svensson, and I'm the Business Development Director of Apex 10. And if we go to the next slide, we have a quite brave statement for our utility customers, and that is that we want to make their infrastructure reinvestment budgets 10 times more valuable. And what that means is that we basically want to improve efficiency when it comes to making the right decisions for replacement in the pipe networks out there, both for sewer networks and for drinking water or potable water. And next slide. And basically, yeah, we are a company coming from the Nordics, but we also not only IT experts, but we also come from the water domain. And originally, we are a company coming from a water consultancy in the Nordics. So we know about the water domain and are now owned by a private equity company in the US called Cimbria Capital. And we also got a minority investment from Aliaxis, a leading pipe manufacturer for the water industry. And what we do is an off-the-shelf solution. So we offer a cloud-based asset management tool for especially the mid-sized utility segment, where we saw a need for an off-the-shelf solution, basically that works based on the existing systems that they have out there. And right now we have a 20% market share on in the Nordic market, in our home market, and are expanding now, looking to expand globally. And as you can see from the last bullet point here, we have a dedicated focus on the water network. So that is basically the domain that we are coming from. And if we go to,
I'm sorry, could I just break in? I think this is a good question in the chat that's definitional, but how do you define mid-sized system in this context?
yes, that's a great question. That is mid-sized, and at least from a Nordic perspective. So we see that the very large utilities often have you could say, a wish to also make own developments or customizations, whereas the mid-sized segment also have you could say, a need for an off-the-shelf solution that is not customized to the individual utility, but works throughout the utility market, so to speak. And what we do is basically, from what we can see here, is tap into a lot of different data sources. So as we can see from the right-hand side, we have a lot of different data sources already available at the utilities right now as of today. So there is SCADA systems, there is GIS, network information systems, CMS, smart meters, and all of that is what we take into our platform, which is called Data Apex. And what we see is that the use of these systems at the utilities is often divided or split into silos, so that the operational departments maybe are working in one tool, but it's not the same, or there is at least a barrier to cross when coming to the next department, or the department next door at least. So we want to have it all compiled into one platform where you can easily access this and speak one language throughout the organization, basically. So what we do with the Data Apex is that we are, you could say, generating value on top of these different data points that we take in and add our analysis on top of that. And we are vendor agnostic. So no matter which type of, you could say, software or hardware providers you have, we can take in that data and are applying our own, you could say, data models on top of that. So we read all the different type of data that there might be in from the utility perspective. That is our philosophy, that we work with a broad range of vendors out there. And you could say our mission is also that you get one step closer to perfection, even though it's not full perfection, then you get an increase in precision when it comes to doing the right reinvestments in the network. And if we go to the next slide, we can see again from the figure on the left-hand side, which is an indicator of why we're called Apex to begin with, is that if we look at the pyramid, then we are aiming towards the top of that, which is what we refer to as the strategic apex. So we have a lot of data from utilities that we capture, we add analysis on top of that, and then we, through you could say intuitive visualizations, we make that tangible for the decision makers in terms of making sure that there is the right priorities for reinvestments of the network. And as we can see from the right-hand side, we have a bunch of modules on our software platform. We have different headlines, whether it's a utility overview of their current data. One of the aspects here is data quality, which is a very important module, especially for new customers getting on board, that no matter what kind of data quality you might have as of now, this is actually a tool for you to use and also make exports into your current systems to continue improving the registration on, for instance, your pipe assets, and making sure that whether it's the material or the date of establishment, all of that you have an overview in the platform as well. And then we have the headline in the middle called asset management, and that is you could say a classical risk profile that we have, combining the consequence of failure with the likelihood of failure. So we're not only looking at the condition of the pipes, where we do machine learning and advanced algorithms to calculate the condition of the network, but we also look at what kind of consequences there is if you need to replace a pipe somewhere. Well, then it's a big difference if you need to replace a pipe near a highway or a railroad, for instance, compared to a park or a field somewhere. And then on the right-hand side, we have some water and wastewater specific challenges. So for wastewater, we are looking into inflow and infiltration, for instance, making calculations in regards to how costly is it, and where are the areas where we can benefit the most by replacing the network, basically. We're looking into sewage overflow and also hydrogen sulfide for wastewater. And all of that is basically your decision paradigm, or when it comes to reinvestments, you need to balance all of these different elements somewhat. And that is what we do, and enable the utilities to compare all of these different kind of parameters that you may have. And then we are, you could say, offering a module where you can take that and make your own decision paradigm based on that, basically. If we go to the next slide, we can see some of the visualization behind it. So this Apex module, where we combine all of the different analysis, is basically providing the utilities with a prioritized list for their individual pipe segments, scored individually based on the analysis that we do. And again, this is very much up to the utility how to differentiate and balance the different decision criteria that they may have. So depending on the importance of, for instance, the condition or the consequence of failure, you can adjust that basically to your own liking. And just underneath, we have this utility overview. So we're looking into both the raw data, but also economical or financial impact by replacement or the network in general. We're also looking at the raw sensor data and providing a platform for the organization to share that amongst the different departments. And as I also mentioned, the asset management with the likelihood of failure and consequence of failure. And lastly, the sewer challenges, where we have an illustration here of the rainfall events and how that then you could say have an effect on at the end at the treatment plant, how much you're actually then having to deal with at the treatment plant by having, you could say, inflow or infiltration in your sewage network. If we go to the next slide. So basically to implement our solution, we have three kind of important bullet points here. So this is a risk-free and kind of a fast implementation that we have for our product. This is not a product where we employ a lot of consultants to make sure that this is up and running specifically for a particular type of utility. This is built for several utilities with data models behind it to convert different type of data. So we are able to implement this in a couple of weeks for our customers, making sure that they are getting actionable results rather quickly. And all of this happens without their involvement or their need to involve their organization, basically. We make sure that that we take on the challenge when it comes to the implementation of this product. And all of this is based on the existing data that is out there at the utilities. We haven't come across any utility that doesn't have enough data to already get actionable insights when it comes to improving the reinvestment decisions, basically. So this is something that we build on top, and basically everybody can get on board, since we are also data or vendor agnostic. So if we go to the last page, we can see what results the utilities are getting, basically. And that is to also make sure that you attract a new generation of utility leaders or workforce. There's a lot of utilities out there having difficulties employing a younger generation of people, especially working with IT. And this is a tool that they can also use for initiating new effective workflow throughout the organization, basically. And yeah, as I've mentioned before, this is quite actionable and tangible insights for improving the precision when it comes to making the right decisions for reinvestments, and not only making it based on guesswork or you could say subjective opinions. This is fact-based, based on the data that is already out there, and you can basically enhance your decision-making from this.
Right.
And then in the end, you have quite significant savings, but also less dependencies on consultancies, and also a more effective workflow, basically. So so that is the bullet points that we have from our side.
Great, thanks so much, Lars.
Yeah.
And I know there was a question about the kind of customization and integration that is required to get everything talking to each other, but I wonder if you could, if there's more you could share about that in the chat. We do need to move on, but really appreciated that terrific presentation. It was great. Our final presentation of the day on digital twins is coming from Henrik Sorensen from DHI, here to talk about twin plants. So Henrik, over to you.
Thanks a lot, Lena. I'm Henrik Sorensen. I work for DHI. I'm based in Copenhagen, Denmark. And I spent most of my time on working with digitalization and different types of digital solutions. One of them is Twin Plant, which is designed for real-time control of wastewater treatment plants. Next slide, please. And what we do with Twin Plant is to try to improve the operation of wastewater treatment plants measured on different types of KPIs. These are some of the KPIs that we often work with. The upper row there is KPIs that we see more or less all the time around process efficiency and energy and cost efficiency. We see that on almost any plant that we work for. The middle KPIs, the middle row there are KPIs that we often see around creating more plant capacity, working with resource efficiency and carbon footprint. And the lower row there are KPIs that we see sometimes, but I think we will see them more and more in the future. And that could be around health, it could be around water reuse, and it could be around hazardous substances. Now, Twin Plant actually builds largely on existing infrastructure and existing data, and we actually see that often you will be able to reduce your energy consumption by around 20%, and you will often see that there is a really good business case in this. Often you will see return of investment in around a year. And if you want to sharpen your green profile, then of course you can quite easily link many of those KPIs here directly to some of the sustainable development goals. Next slide, please. And if we look just a little bit under the hood, then Twin Plant contains four packages that we call the automated plant, the learning plant, the predictive plant, and the optimized plant. And the starting point is often the automated plant, where we simply take real-time sensor data from the physical system. And with those sensor data, we calculate set points. That could be the pumping rate or the blowers or the valves that we control with those set points, and we feed them back into the physical system through the SCADA system. So that's kind of a basic data-driven control loop that there is a lot of value in taking just that step. And the next step is then where you move into the digital twin arena. That's where we start to have, you can say, virtual representations of the physical system in the form of detailed process models that simulates all the physical and chemical processes in the plant. The first one here we call the learning plant, and that will allow you to start experimenting with how you operate your system. You can start to fine-tune the way you calculate your set points that controls the blowers and the pumps. But you can also do more classical what-if scenarios, like what happens if you get 50% more inflow to your plant, or what happens if the composition of your inflow changes a lot. And the next step, the predictive plant, simply adds a forecast to your system. Especially if you work with combined sewer systems, it can be useful to have an inflow forecast, which you can make based on different types of weather forecast products. And the last step, the optimized plant, is where you have a fully automated optimization of your plant, where the optimizer tries to optimize the set points so that they best meet your target KPIs. The next slide, please. We have used this, especially the automated plant and the learning plant, at a number of sites around the world, and I just have some very quick cases here where we have implemented the Twin Plant. The first one here is on Viby wastewater treatment plant in Denmark, where the client was facing a need to increase the capacity from 90,000 to 120,000 PE at the lowest possible cost, basically to keep the plant alive for another 10 years until it would be replaced by a new plant and then discontinued. And we actually managed to do this by implementing sophisticated real-time control and doing some minor infrastructure investments. And I think that this is quite typical, that you can get really far with a real-time control, but often you will have to do some minor infrastructure investments as well. But compared to the infrastructure investments you would have to do without real-time control, this is probably this is a fraction. The alternative would have been investments maybe in the order of 15 to 20 million euro. Next slide, please. We stay in Denmark with this one. This is Marselisborg wastewater treatment plant, which is slightly larger plant also in Denmark. And the client here, Aarhus Vand, had a vision to become an energy producer rather than a consumer. And this treatment plant has actually, I think, for the past 8-9 years been energy positive. They produce on average probably around 50% more energy than they consume, and they sell that energy and then create a continuous income from that. So that's also a very good case here from Denmark. And the last one I would bring in, next slide, please, is from Portugal, where a smaller plant, a study which a solution which we are actually just finishing now, which is a client that would like to become energy neutral and also looking at reducing the costs. And with the first step here, we didn't quite reach energy neutrality, but we did manage to increase the electrical self-sufficiency from 20 to 60%. And we also managed to find another 30,000 PE, so increase the capacity by 30,000 PE, which actually allowed the client to decommission one of the small existing plants, and then of course save quite a lot of money on costs and energy. And we have a number of cases, including a couple upcoming in the US, but this was just a quick flavor of what I had to show. So thank you. Next slide, I think. Yep.
Oh, that was excellent. And what a wonderful place to wrap us up on helping utilities achieve these net neutrality, energy neutrality commitments that, we've just passed landmark climate legislation here in Illinois. Utilities will be a big part of helping us reach that, those energy goals, reducing the energy consumption that they use. So perfect place to wrap it up this COP26 week, as we are all thinking about how to help achieve climate commitments globally. So I thank you for that presentation. Also to everyone else, George, Steve, Lars, thank you so much for the terrific presentations. I hope everybody will reach out and continue. There were lots of questions in the chat, and I think a few we did not get to answer today. George, if you want to go to the next slide, we've popped up a poll. We're always interested in audience satisfaction on the content of these events. It helps us plan for 2022. We have an upcoming event, our monthly Third Coast Water Seminar Series on water quality modeling and optimization and distribution systems. So again, building on some of Jun Hong's opening framing, always interested in more and better data to control for these optimized systems in water. So continuing on that theme for our last Third Coast of 2021. Please stay tuned and follow Current if you don't already. We have an Eventbrite page that is constantly updated. We, as I mentioned before, have a YouTube page where all of the content from these events and more is included. Reach out to us directly. I really appreciated some of the comments in the chat today from other partners who are thinking about helping utilities, bridge over to this digital future that we know we need to see to improve outcomes. George's contact information is on screen here. Always interested in your ideas for events for 2022. Our calendar is shaping up rapidly, but we do still have some space to think about events and new partnerships next year. So thanks once again for joining us for Water Around the World, and big thanks to our partners at the Danish Consulate for just taking the leap of faith with us this year and doing 4 events to highlight all of the wonderful achievements of Danish companies in this space. We are glad to be bringing you to our market here in the US and look forward to the exchanges that develop as a result. So thanks everyone for being here. See you soon.
Thank you. Bye-bye.